Good morning, student. Welcome to my class. Last class we discussed what is triangle of vector addition and parallelogram law of vector addition, and at that time we find a resultant relation, that is r equal to a plus b, and its magnitude is important, that is r magnitude or resultant magnitude of two vector, that is a square plus b square plus 2ab cos theta under root over. And what is theta? Theta is angle between a vector and b vector, and we already discussed if vector a is here and another one vector b vector, this is parallelogram law of vector. And now first we have to make a parallelogram, then resultant which passing through the diagonal and common point of a and b, and this angle is angle between a vector and b vector, which is theta, and this resultant r and its magnitude, this is r vector equal to a vector plus b vector, but its magnitude we already find a square plus b square plus 2ab cos theta under root. What is theta? Theta is angle between a vector and b vector. This is most important factor. Clear? Okay. Now we already find the direction of resultant vector from vector a vector. So this angle is alpha. What is alpha? Alpha indicate and it show the direction of resultant vector from a vector. Clear? And its magnitude we already discussed, that is tan alpha equal to b sin theta divided by a plus b cos theta. This angle is known as alpha. Clear? And its special case, different special case of parallelogram law of vector addition. Now let's start. This is two vector. When two vector which possess both direction and magnitude, at that time we need to use triangle law of vector addition and parallelogram law of vector addition. But when number of vector means more than two vector which possess both magnitude and direction, and the direction at arbitrary direction, you can say direction which is different, the direction of all the vector are not along the same direction. Clear? So at that time we need to use the third type of vector addition, that is known as polygon law of vector addition. Clear? So now let's start polygon law of vector addition. Polygon law of vector addition. So now let's start. What is polygon law of vector addition? Means if number of vector possess both magnitude and direction, represented by an open polygon. Taken in same order, then the resultant vector also possess both magnitude and direction, then resultant vector possess both magnitude and direction by closing side of a polygon or open polygon, and taken in opposite order. taken in opposite order. This is definition of parallelogram law of vector addition. Suppose there is number of vector when more than two vectors are represented both magnitude and direction. At that time we have to use polygon law of vector addition. Clear? So suppose there is a vector this direction, and this vector is a vector, and another one vector, suppose here another one vector is b vector, and you can say another one vector is here c vector, and you can write also another one vector is d vector in one plane. Clear? At that time we have to find resultant vector of all these vector sum. Clear? So how can we find this resultant vector of a vector, b vector, c vector and d vector? So in this case we need to use another one type of vector addition, that is known as polygon law of vector addition. Clear? So in this case, now first we have to prove by using graphical representation of polygon law of vector addition. We already know shifting of vector. So what is shifting of vector? Shifting of vector means we have to shift a vector from one position to another position without change its magnitude and direction. That is known as shifting of vector. So by using this concept, here a vector, now shift this vector a is here, this is vector a vector, and another one vector is here b vector. Now we have to use tail to head method. This is tail to head method and b vector without change in magnitude and direction. Without change in magnitude and direction. Next, another one vector c vector. Then join the tail of c vector to head of b vector. This vector. Clear? Vector c, this direction, and another one vector is d vector here, and this vector is known as, this is the direction and magnitude of another one vector is d vector, and these four vector which represent both magnitude and direction by an open polygon. This is open polygon case. Clear? Then at that time the resultant vector which possess both magnitude and direction represent the closing side of the polygon. This is closing side. So here we have to draw another one vector which represent resultant vector and its direction, its order which is opposite order, taken in opposite order, and this is known as resultant vector, means R vector. Clear? So a vector, b vector, c and d which are same order, but resultant vector is here opposite order, and this resultant vector possess magnitude and this resultant vector also possess direction. Clear? This triangle law actually one of the you can say application of parallelogram law and triangle law. So this polygon law. Now we have to prove here this resultant vector which consists, that is vector a, b, c, d. So you can write here a vector plus b vector plus c vector plus d vector. Clear? So this polygon law can be proved by using triangle law of vector addition. Clear? So how can we use triangle law of vector addition? This is the final answer, and resultant vector can be found by using this relation here. Clear? Now we have to prove how can we find this resultant vector is here, that is R vector equal to sum of a, b, c, d. Now look at this diagram. Suppose this point O, I am writing here M, N or M, N, O, P. M, N, O, P, Q. Clear? So here M, N, O, P, Q, which is a polygon here, and this MNAB which represent same order, and now we already discussed this is the third side, and this resultant vector can be write, suppose R1. What is triangle law? If two vector represent same order, then resultant vector will be opposite order, and this is known as R1. Clear? So by using triangle law of vector addition, to the triangle. Which triangle? Triangle MNO. Triangle MNO. At that time we can find the resultant vector, that is R1 vector, which is equal to sum of two individual vector which are same order. So A vector plus B vector, this is equation number 1. Similarly, there is another one triangle MOP. So in triangle MOP, by using triangle of vector addition, this triangle MOP, and this is resultant vector. Why this is resultant? Because R1 vector and here C vector, R1 and C, which are same order. So this is resultant or closing side you can say, and which represent, that is we can write here R2 vector. Clear? So here by using triangle law of vector addition to the triangle MOP, the resultant R2 vector equal to R1 vector plus C vector. C vector, equation number 2. Similarly, here another one triangle MPQ. So in triangle MPQ, in this triangle, if we use triangle law of vector addition, here R2 and this vector D, R2 vector and D vector which are same direction. So in this case we can write the resultant vector, this vector is R vector. So R2 plus D, R2 vector plus D vector are same order, but here this is closing side this triangle, and here resultant vector is R vector. So triangle MPQ, by using triangle of vector addition, resultant vector which is equal to R2 vector plus D vector, R2 vector plus D vector, equation number 3. Now use all the value here. R2 is given R1 plus C. Now from equation 3 we can write the resultant vector R2 vector plus here D vector. And what is R2? R2 is here R1 plus C. So R1 vector plus C vector plus D vector by using here equation 2, this relation. Clear? By using equation 2 we get this relation, means resultant vector. Again R1 vector given that A plus B, so use here value, this value, then R vector equal to A vector plus B vector, A vector plus B vector plus the remaining vector C vector plus D vector. This is proof. So in this way you can prove the parallelogram law of vector addition, means if number of vector or more than 2 vector represent magnitude and direction, so by using triangle law you can prove resultant vector equal to R vector, A vector plus B vector plus C vector plus D vector. Now let's start properties of vector addition. Properties of vector addition, we discuss 3 vector law, triangle law, parallelogram law and polygon law. Now we have to discuss here properties. So first properties, that is known as law of vector addition. Law of vector addition obey commutative law. So what is commutative law? We know that if A plus B equal to B plus C, then this law is known as commutative law. A plus B equal to B plus C. So we have to prove here A plus B equal to B plus A is here. This is commutative law. Suppose there is a vector A vector and whose magnitude A, and another one vector, suppose B vector is here, which makes angle theta with A. Clear? So in this case we have to prove A plus B. Now first we have to prove A vector plus B vector is here. So first shift the vector A plus B. Now first shift vector A, this is A vector and its tail and here head point indicate, And next, now we have to shift vector b vector by parallel shifting method. Now place the tail of b vector on head of a vector without changing its magnitude and direction. This is b vector. And what is resultant vector? The closing side, the third side of the triangle is known as resultant vector. And here resultant vector you can draw. This is resultant vector, and resultant vector always taken in opposite order. A vector, b vector same order, but here resultant which is opposite order. This is a plus b here. Clear? Okay. Now next find b plus a. B vector plus a vector by using, this is graphical method proof, and you already know resultant, how to find resultant. A square plus b square plus 2ab cos theta under root in this case. Clear? So next b plus a. Now first shift b vector and here b vector like this. Without changing its magnitude and direction, we can shift a vector from one place to another place. Again another one vector, a vector. Now we have to join the head of first vector. This is head of first vector and tail of second vector, means here a vector, without changing its magnitude and direction. Clear? Now the closing side represent resultant of these two vector, and this represent resultant vector, means here r vector, and resultant vector here, that is a vector plus b vector. Clear? So here resultant r equal to a plus b and r equal to a plus b vector, or you can write this vector b plus a. B plus a, here r equal to a plus b and r equal to b plus a. R are equal, so we prove here that is a plus b which is equal to b plus a, means vector addition follow commutative law. So there is another one property that is known as associative law. Associative law which obey vector addition. Vector addition. What is associative law? Here a vector plus b vector plus c vector, means a plus b vector which is equal to, you can write here a plus b vector plus c vector. This is known as associative law. You can prove by using this method or graphical method also. Clear? And another one law is here. Suppose if we use multiply with a scalar, a plus b vector multiply with a scalar vector which equal to, that is a vector plus lambda b vector. Here lambda is scalar quantity. Clear? So we can write directly this method. This is the properties of vector addition. Let's start condition for zero resultant, and that is also known as equilibrium of vector or equilibrium condition of vector. So what is equilibrium condition? If number of forces, or you can say if three forces, suppose first I am taking here, there is a particle. If three forces acting simultaneously on a particle, these three forces is here. I am writing here A, B or C, or you can say three vector acting simultaneously. If three vectors acting simultaneously on a particle, three vectors acting simultaneously on a particle, then their resultant vector will be zero vector, or resultant vector will be zero. How? Suppose this is particle A, B, C which acting simultaneously. Simultaneously meaning कौन? एका समय रे simultaneously act माने एका बेले तीनटा फोर्स पड़िया A B C on a particle. Now represent this vector in tail to head method. Means A vector is here, so this is head vector, parallel shifting of vector. Another one vector is B vector is here, so this direction is B vector, and another one vector is C vector, which is downward direction, and C vector is downward direction is here. Clear? Suppose this angle is I am taking here 120 degree, and this angle 120 degree, and this angle also 120 degree, then this vector which represents C vector. So what is resultant here? This is initial point and this is also final point. So in this case resultant vector is 0 vector. Clear? So resultant vector is 0 vector means here A vector plus B vector, A vector plus B vector plus C vector, because these three vectors are in same order. So here A vector plus B vector plus C vector, which is equal to 0 vector. This condition is known as equilibrium condition. Equilibrium condition of vector means if three vector acting simultaneously on a particle, and if this three vector which represent a closed triangle, this triangle is closed triangle, then resultant vector is here and resultant vector will be 0 vector is here. Clear? This is law. A vector plus B vector plus C vector which is equal to 0 vector. Or you can prove, suppose there is vector A, another one vector is B, and find resultant of these two vector, and here this is the direction of resultant vector which is opposite direction, and suppose this resultant vector is here R vector. So I am writing here R vector equal to A vector plus B vector. Clear? Okay. Now come to this triangle. Here A vector plus B vector plus C vector, and I am writing here that is A vector plus B vector which is equal to minus C vector from this relation. Clear? So here R vector which is negative of here C vector. Clear? And this R vector which is C vector equal to C vector, but this is this direction, here opposite direction, and here R vector which is negative vector of C vector is here. So if you use the relation minus C equal to, you can write A vector plus B vector. That means A vector plus B vector plus C vector which is equal to 0 resultant. This is the condition for 0 vector or equilibrium condition if three vector acting simultaneously on a particle. Clear? Okay. Suppose 4 vector acting on a particle simultaneously. For 4 vector which represent a closed polygon, you can take, suppose there is a particle 4 vector acting simultaneously, vector A, another one vector B, and another one vector C, and another one vector D vector. Find resultant vector here. So in this case, if acting simultaneously on a particle, then this is vector A and second vector B vector, means second vector is here B, and third vector C, and this is the direction of C vector, and fourth vector D, and this is the fourth vector D. Means initial point and final point is 0 here. So in this case we can write directly A plus B plus C plus D vector which is equal to 0 vector. Means this is a closed polygon. Closed polygon. Clear? So 3 vector or 4 vector or 5 vector acting simultaneously on a particle, then the resultant, if they form a closed loop or they form a closed path or closed polygon or closed triangle, so at that time we get a resultant vector, and the resultant vector is here 0 vector. They must possess a closed polygon or they must possess a closed triangle. means same order, then the resultant will be 0. Here same order, then the resultant will be 0. This is the condition for equilibrium condition. Clear? Now let's start subtraction of two vector. Subtraction of two vector. So how can we subtract two vector? Clear? Suppose there is a vector A which possesses both magnitude and direction, and another one vector is B vector. This is direction theta. Suppose B vector is here. Now we have to subtract here A vector and B vector. So subtraction means here we have to subtract A vector minus B vector, which is resultant vector. We can say that is R vector is here, and this vector is known as subtraction of two vector. Clear? So in this case, look at this diagram. Now first shifting the parallel shifting of vector A. So this is parallel shifting of vector A without change its magnitude and direction. Clear? Okay. This is another one vector, B vector is here. So how can we find angle between two vector? To find angle between two vector, first we have to know, or first we have to join their tail to tail or tail to tail method. So this is the tail of B vector and here tail of A vector. So now join their tail to tail. This is tail of A vector and this is tail of B vector, just like parallelogram law. So this vector is known as B vector is here. Or if we draw here, this vector is A vector and another one vector is B vector is here, and this angle is theta. So theta is angle between A vector and B vector. You already know what is negative vector. If a vector which indicate this direction and another one vector which is opposite to direction, this B vector, means here we can write A vector negative of B vector. Their magnitude are equal but opposite direction. So in this case, negative vector means there is another one vector we can draw here. This A vector is, this is B vector, or you can say if this vector is A and another one vector which is minus A vector, these are negative vector. So how can we place? Because this is vector B and this is negative vector and this is known as minus B vector. But you can shift the vector this place to this place without change its magnitude and direction. Without change its magnitude and direction here. Clear? So this is the parallel shifting of vector, and we shift the vector is here, and this vector is minus B vector here, and in this case theta how much? 180 degree, and here angle also 180 degree, and this is plus B and this vector is known as minus B vector. Now we have to find its resultant of A vector and B vector. First we have to draw a parallelogram condition. You can say this is parallelogram, and if two vector A and B, suppose this is B, A and B represent both magnitude and direction and passing through a common point or intersect at a common point, then first we have to draw a parallelogram. Now the resultant which represent the diagonal of the parallelogram and passing through this common point, this is common point, and here this is resultant vector R vector, and how much? This R vector which is equal to A vector plus but here minus B vector. Clear? This is also known as addition of two vector, but one vector is positive, another one vector is negative, and you can say another one vector is here. Suppose this is B and here this is B vector, and if you draw here, this is negative vector minus B vector. Clear? Okay, we have to draw a minus b. So this is first a vector, vector a, and another vector minus b. Now shift parallel. So this is known as here minus b vector, addition of vector. Now join their tail to head, and this indicate the resultant vector r vector, and here r vector equal to a vector plus minus b vector means a minus b vector, and this is the resultant means a minus b vector. Or you can shift this vector b vector you can shift here. Clear? If you shift b vector here, then this vector is b means here minus b, and this vector minus b, and direction, and this is also direction. So a vector plus b, but here negative sign, a vector plus minus b, which is equal to resultant vector. Clear? This is known as subtraction of two vector. But in subtraction of two vector, how can we find its magnitude and direction? We get this is vector quantity, but it possesses both magnitude as well as direction. So how can we find magnitude? Because we already know in parallelogram law of vector addition, that is r vector resultant vector, which is equal to magnitude of a vector square and here b square plus 2 into a b cos theta. What is theta? Theta is angle between two vector. Two vector means here two vector a and b, but here angle between two vector, angle between a vector is here, angle between a vector and this is b. Or minus b is here also minus b, angle a vector minus b. This angle is known as angle between a vector and minus b, and this angle is theta equal to 180. So this total angle is known as 180 minus theta. So here the angle between a vector and minus b vector, which is equal to 180 degree minus theta. So you have to use here angle 180 degree minus theta. Clear? And this is resultant under root. And what is r is here? R equal to a vector minus b vector. So we can write here a vector minus b vector magnitude, which equal to a magnitude square means a square, simply b magnitude square is b square plus 2ab cos 180 minus theta. Here second quadrant means 90 above 90 and 180, between 90 and 180 degree. So here cos 180 minus theta, 180 minus theta means second quadrant, and second quadrant add sugar to coffee. Only sign function positive here in second quadrant. Clear? So this is cos function, so cos function negative. So first we have to write here minus cos, because 180 degree. If there is angle 90 and 270, then sin changes to cos and tan changes to cot and sec changes to cosec. But here 180 degree, so we have to write here minus cos 180 degree, which is equal to minus cos or cos 180 degree minus theta, which is equal to minus cos theta under root. Now solve this relation here. So a square plus b square plus 2ab cos theta, but a negative sign here, negative sign. This is known as resultant vector, that is a vector minus b vector magnitude, or simply you can write r resultant in this case. Clear? This is the resultant vector, and suppose this angle is theta, this angle, sorry, you can write this angle alpha. Then find direction. Alpha represent the direction of resultant vector from a vector. केते डिग्री एंगल पछ दे की वेक्टर जाउची, resultant vector जाउची from a vector बाहर करिया. So now using tan, you can use tan function is here. So tan alpha equal to again b sin theta, means magnitude of b sin theta. Theta is here 180 minus theta. divided by A, magnitude of A plus magnitude of B into cos theta 180 degree minus theta. Clear? Or you can write that is tan alpha equal to B sin theta, B sin 180 minus theta, 180 minus that is second quadrant sin function positive. So you can write here only sin theta divided by A minus B, because 180 minus theta second quadrant and cos function negative is here, so you can write minus B cos theta. This is the direction of resultant vector. Clear? So in this way you can calculate the direction of resultant vector or subtraction of two vector by using this concept. Clear? Okay. And this subtraction of vector, you can write properties of subtraction of vector. Properties of subtraction of vector. So how can we subtract? Its properties means can we write A vector plus B vector? Can it follow the commutative property A vector plus B vector, which equal to, or A minus B vector which equal to B minus A vector? No, this is not equal. Clear? How? Suppose one vector is here and another one vector is here B, and this angle suppose theta. Now prove this relation LHS. LHS means A minus B vector is here. So in this case, this is the resultant vector A and minus B. This is B means minus B, which is opposite to this direction. So this is minus B vector. Clear? And here we get the resultant vector. You can say this is B vector and you can shift here. I am just write the simplest method is here. So this is A vector and this is minus B vector. Clear? And here resultant vector is this vector, is known as resultant vector, means R vector, this direction. Now come to right hand side, RHS, B minus A. So here this is B vector, B minus A, this is A vector and its negative vector means here minus A vector. So B vector is here B minus A, this is B minus A vector is here, so this vector is A is here. Clear? And this B vector and minus here minus A vector, and this, so here this is B minus B, A minus B, so resultant is here A vector minus B vector, this is the resultant and this direction. But here B vector minus A vector and this is the resultant vector. Suppose this vector is R dash, so R dash vector equal to how much? B vector minus A vector. That means R vector does not equal to R dash vector. So subtraction of two vector do not obey commutative law of vector addition. Clear? So this is the concept of subtraction of two vector. Clear? And important concept here you can write here A vector and this vector is B vector, and this resultant of two vector means this indicate resultant vector and here angle theta, here R vector. We already proved in parallelogram law of vector addition, A vector plus B vector is here and this angle is alpha, that is direction of resultant vector from A vector. If this is the direction of minus B vector or negative vector, then you can draw This is closing side, this side, and which indicate the resultant vector. And suppose this resultant vector, that is r dash, which is equal to a vector, because this vector a vector plus this can be shift here, a vector plus b, because this is minus b. So r dash, this is r dash vector, r dash equal to a vector minus b vector. Clear? And this vector means resultant of a vector minus b vector, and this is smaller diagonal and this is the large diagonal. So if you draw a parallelogram here, and this is the large diagonal, and large diagonal indicate that a plus b, and this smaller diagonal indicate that that is r dash equal to a minus b vector, and this diagonal which do not pass through this common point, where this point a and this point b. Clear? This is all about subtraction of two vector. Now let us take one example regarding subtraction of two vector. Suppose there is a particle which moving in a circular path with constant speed. This is circular path and this is center. The particle which moving constant speed constant in a circular path, and there is 2 points. Suppose this point A and another point is B here, and suppose this is radius, you can say r, and this is also radius is here r, which make an angle theta. This angle is theta. Now find the average speed. You can say find average speed between A and B. Question asks, if a particle is moving in a circular path with constant speed v, find average speed of the particle. Average speed means this is between 2 points. This is point A and this is point B. Because velocity is a vector quantity, here we have to draw a tangent, and this tangent like this, and this is known as velocity v1 at point A. Similarly at point B, first we have to draw a tangent here. This shows the direction of v2 vector. Here speed constant. Here speed means magnitude of velocity, here speed, which is constant, but velocity here variable. Velocity variable. Each and every point velocity change. A point ro velocity, B point velocity change kon bai na A point ro magnitude ठीक अछि, डायरेक्शन में थाके, B point डायरेक्शन में थाके, तले velocity change हेला. तले ए पॉइंट रा में बाहर करिया चेंज इन वेलोसिटी टा केते, ये ए पाखे जाउतिला, ये चेंज हे के पाखे पड़े गला, बुझि होजी. बट वी कैन शिफ्ट द वेक्टर. ये जो v1 वेक्टर अछि, ए v1 वेक्टर को हम एडी कोन कर परिबा, शिफ्ट करि परिबा. क्लियर? सो नाउ बाय यूजिंग द मेथड ऑफ शिफ्टिंग, दिस इज वेक्टर a. सपोज दिस वेक्टर इज a, here this vector a is here, or v1 vector at point a is here v1, this point is a. Similarly this vector change its direction to v2, and there is another one vector, this point I am writing here, this vector is now I am drawing here, this point is v1 vector, and here this is v2, and this vector is here v2 vector. If this angle theta, draw a parallel, then this angle also theta. Clear? If this angle theta, this total angle is 90. This total angle is 90 degree. Theta means this angle 90 minus theta. So this angle will be theta, because this total angle also 90 degree. So this angle theta. if this angle theta, then this angle also theta. So this angle is here theta. Clear? Now we have to find change in velocity. V1 to V2 change hela. So this is known as change in velocity. Are V1 plus this change. Suppose this change ko mu lekhuchi the delta V vector. Clear? So V1 vector plus delta V vector equal to kate? How much? That is V2 vector. But angle between them, how much? V1 and V2 is theta. So if we use here triangle law, by using triangle law of vector addition, you can write V1 plus delta V. V1 plus delta V vector equal to V1 plus delta V, same order, which is opposite order, and that is equal to V2 vector. What is magnitude by career? So you can write here delta V, change in average velocity magnitude by career. So delta V, which is equal to V2 vector minus V1 vector, negative vector concept. So in this case, how can we find its magnitude? That is V2 vector minus V1 vector magnitude, which is equal to V2 square, or magnitude of V2 square, or this relation can be right V2 plus minus V1 vector. So V2 square plus magnitude of V1 square plus 2V1 V2 into cos theta. And what is theta? Theta is angle between two vector. Here two vector V1 and another vector V2, and is here angle is theta. Clear? So you have to always remember what is the angle between two vectors. Theta is here under root over. So delta V magnitude, which is equal to V square or V1 square plus V2 square plus 2V1 V2, 2V1 V2 cos theta under root. But here magnitude is constant. This is constant speed. So constant speed, particle moving in a circular path is constant speed. So V1 vector magnitude equal to V2 vector magnitude. ये constant. We can write here suppose V. A point speed is a point speed समान. But खाली direction change हो सकता है, velocity change है वाला. Because velocity is a vector quantity and speed is a scalar quantity. So if magnitude of V1 equal to V2 equal to V, then we can write here that is V square plus 2 V1 V2 V square cos theta under root, which equal to common V square 2V square plus 2V square cos theta under root. Clear? So here delta V equal to 2V square common. So 2V square 1 plus cos theta under root. The root. Clear? This is trigonometric identity. So 1 plus cos theta, which is equal to 2 sin square theta by 2. This is trigonometric identity. You have to use this relation here. So delta V equal to 2V square into 1 plus cos theta equal to 2 sin square theta by 2 under root here. So 2 4 V square sin square theta by 2 under root, and which equal to 2V sin theta by 2, which is equal to delta V. Clear? This is another one format. So here change in velocity between point A point and B point, which is equal to delta V, and its magnitude, that is 2V sin theta by 2. Clear? So by using subtraction of vector. So these are all about polygon law of vector addition, and what is the equilibrium condition, what is properties of addition of vector and subtraction of vector. Clear? Thank you all.